Hello, my name is Azim, and this is our poster presentation on tower cranes. If you take a look around you at all the buildings that are so impossibly high, you find yourself wondering how we built these structures so high up. Enter the remarkable invention of cranes. Cranes are marvelous machines that have played a pivotal role in the shaping of our modern world. They are versatile mechanical tools designed to lift and move heavy loads efficiently. Their utility resides in significantly boosting productivity and safety across parts such as construction, manufacturing, and shipping by skillfully handling considerable amounts of loads. Crafted through precise engineering and meticulous quality control, cranes undergo careful manufacturing to ensure that the strength and durability of the machines are optimized. On construction sites, careful planning, crane type selection, assembly, and secure placement must all be taken into consideration before any and every use of the cranes to ensure safe and efficient operations. Safety remains paramount with methodical inspections which include load capacity assessments and operator certification needed to safeguard all workers and environment during crane use. What are cranes? Cranes are characterized by several key components, which include hoist mechanism, boom, counterweights, sheaves, and control system. At the heart of a crane lies the hoist mechanism, which is responsible for lifting and lowering loads. It usually consists of a winch drum or a motorized drum, equipped with chains, cables, or wire ropes to move the loads. The boom extends horizontally from the crane's mast and serves as the primary arm for reaching and positioning loads. The length of a boom can vary depending on the type of the crane and the intention of its use. The current cranes are equipped with a control system that allows crane operators to manage the crane's movement and function with ease. Cranes are also equipped with counterweights to maintain balance and stability while lifting heavy objects. These weights are strategically placed on the crane to counteract the weight of the load and prevent the crane to tip over. Sheaves are a pulley-like system that guides the cables from the hoist mechanism to the load. A key component of a sheave is to help distribute the load weight evenly and ensure that the lifting and lowering operations are carried out as smooth as possible. I'll hand it over to Alex.
Hi, this is Alex, and I'll talk you through a few different types of common tower cranes. The most commonly seen one is called hammerhead tower crane, and its jib can rotate 300 degrees horizontally at a fixed level, and it typically length from 30 to 70 meters. This type of crane is mostly seen at larger construction sites with large open space for slewing of the jib. There are also a variant without the A-shaped structure on top of the crane called the flat top cranes. It takes up less headroom and allows space for multiple cranes slewing above or underneath one another. Drawbacks are they tend to have limited lifting capacities compared to A-frame cranes. Another common type is called luffing jib tower crane. It's similar design to a hammerhead tower crane, but the jib is latticed and can be raised and lowered. Jib mobility allows more lifting capacity and especially useful in congested areas because of its reduced slewing radius. It's often seen in urban construction sites. Another common type of tower crane is called self-erecting crane. It includes a horizontal jib and a mast mounted to a ballast. It has the ability to fold and unfold for dismantling and erections on site. It has a lighter frame and transportable, however, also has a much lower lifting capacity and lifting height limits. It's suitable for constructions that requires a tight fit between buildings and without too much requirement for heavy lifting or high lifting. I'll then pass down to Stefan.
Hi, I'm Stefan. I'm going to speak about the safety requirements of setting up a crane on a job site. Before setting up a crane, it is mandatory to undertake a site evaluation to confirm the ground conditions are stable and capable of withstanding the weight of the crane. Surveying tests are used by engineers to determine the soil's bearing capacity. This is then compared to the crane's maximum load capacity, and if it's equal to it or more, then the location is adequate. The location should be flat and free of any indents. The reason why it is so vital to have a strong foundation for the crane is if the surface is unstable or soft, it can lead to the crane collapsing and harming individuals and the surrounding structures. Before using the crane, load tests should be performed in order to confirm that the crane is able to lift the weight it claims to be. These tests involve gradually increasing the load up to the crane's maximum capacity to ensure it can safely handle the weight. Clearing the area of obstructions such as power lines, traffic, trees, or other equipment that might interfere with the crane's operation is essential. If the crane must be positioned in a position that moving traffic would normally interfere, traffic control measures will need to be planned and put into place prior to the setup. This can include closing roads or detouring traffic to ensure that the safety of the individuals in the proximity is ensured. Moreover, only trained and licensed crane operators should be permitted to operate the crane. Before operation, the individual should be assessed if they are aware of all safety procedures and emergency procedures. Additionally, consistent monitoring of weather conditions is necessary, as high winds or heavy rain can pose significant safety risks. If the conditions are dangerous, operations should be delayed and rescheduled. If a dangerous weather condition occurs, after the incident, the soil and surface should be inspected to ensure there are no safety risks. I'm going to pass it on to Nilo.
This is Nile, and I'll be talking about how tower cranes are manufactured. So there are 5 main steps in the process, which include molten steel being transformed into separate parts of the crane using a range of processes that are chosen depending on each individual part. Then precision cutting tools are used to accurately shape and size each part, and pieces of the crane are then compiled together in a separate manufacturing factory. Joining techniques such as welding and bolting are used to join the parts of the crane together, and once all the pieces are compiled together, vigorous tests are done to make sure they meet the requirements and demands of quality for the construction industry. In more detail, molten steel is made by melting iron ore and a rich carbon substance in a furnace, then removing most of the carbon by blasting oxygen into liquid. Molten steel is then poured into iron molds where it can cool, and ingots are shaped between large rollers under pressure. This is to form flat products such as plates and sheets or bars and rods. The diameter of the rod is reduced to its desired size when steel is rolled into a long rod, and several wires are twisted together to form a cable. Steel is then transported to the crane manufacturer to be inspected and stored. Drills and other like machines are used to shape the steel required to form the crane. Steel components are welded or bolted into place as mentioned before. After assembly, the crane is tested and shipped, and it's also possible that the crane may be broken into subsections and then assembled on site. I'll now pass it on to Ashton.
Good afternoon, my name is Ashton, and I'll be briefly covering the concept on how cranes are actually assembled. So before any part of the crane is assembled, a solid foundation must be built beforehand, and this is why we generally use steel reinforced concrete, which is designed to shoulder the crane's weight and all of its loads, and it also contributes to a better tensile strength of the foundation. Embedded within this concrete is the foundational mast section, as you can see here, which is securely anchored by high-grade steel bolts and pins. Once this is done, the first few sections are lifted onto the foundation and fastened together using these steel bolts, as mentioned before. And the climbing frame is also added to the mast section, which allows the crane to adjust its height, which I'll explain later. And so is the slewing unit, which allows full 360-degree rotation of the operator's cab. Then the operator's cab, the cat head, the jib, the counter jib, counterweights, trolley, and of course the hook are also added. And it'll look something like this on this image over here. So as you can see, it hasn't risen to its full height yet. So now in the way that cranes climb is by firstly attaching the frame's hydraulic system connections to the mast section. And this is on the climbing frame. So you can see over here in this image, you can see the hydraulic system. Once that's done, the hook then picks up an additional mast section and positions it right outside the climbing frame. And it also grabs another mast section to keep the whole crane in equilibrium. And once it's done, it'll look something like this. And then once all safety checks have been completed, the jack on the climbing frame compresses and decompresses to climb up each section of the mast until it's risen above the last mast section. And once it's done, the jack decompresses one last time. And then once all safety checks are complete, the new mast section is bolted onto the climbing frame. Now, once all the safety checks have been confirmed again, the crane repeats this process until it's reached its desired height. Thank you for listening to our presentation.
All good.
Is that cool?
Yeah, all good.
Yep, that's good.
Alex, when you fully
Alex, do you need
covered it.
help editing that or anything? Do you need anything from us? Because you've done quite a
That's
bit.
all right. I think I can do the editing. Just I need some time. I need until Thursday to do the editing.
Yeah, that's
Yeah.
fine. That's fine. Just let us know if
I
it
got the
doesn't.
mechanical engineering tomorrow.
Yeah, tomorrow.
Oh,
Yeah,
yeah.
How do you guys feel
Probably
about the exam?
Are you ready for that, guys?
Not
I'm screwed.
totally no.
I see
I'm
I'm
not even
loading
doing
in
it.
torsion so hard.
All right,
Yeah.
let us know if you have any questions. I can help you out on that.
Yeah, all right. If any issue,
Yeah,
I'll let
Alex,
you guys know.
after the meeting, just double check everything's recorded. Because you really
Yeah.
Yeah.
I'll,
Let us know how fluent it is. If it isn't, then worst case scenario, we'll have to